Okay, so we are talking about because we have a DC motors, we have a AC motors. No? So our main emphasis on this that is AC motors. No? So we are categorizing AC motors with respect to its supply. Either it will be a single phase supply or it will be a three-phase supply according to its constructions, right? So when we are talking about the AC motors, either it will be what I would say induction motor or it will be a synchronous motor. So firstly, we will clarify the difference between induction motor and synchronous motor. So the main difference between the induction motor and the synchronous motor, induction motor is a self-starting motor. The synchronous motor, it's not a self-starting motor. So we have to give excitation either by pony motor or by other equipment. So we have to get that motor to the synchronous speed, and after that we are giving the supply voltage. But when we are talking about induction motor, it's a self-starting motor, right? So induction motor, when we are talking, two types of induction motors there. One is the slip ring induction motor, and other is the squirrel cage induction motor. So we'll just go through one by one. So when we are saying what is squirrel cage induction motor, okay. So three phases obviously it will three-phase induction motor is there. The three phases are displayed by angle of 120 electrical degrees. So three-phase induction motor, it's a type of three-phase induction motor, and it will function based on the electromagnetism. Because when we are talking about electromagnetism, right? So electric effect and the magnetic effect also comes into. So that's why we are saying the electromagnetism. When we are talking about DC generator also, whenever the conductor is just rotating in between the magnetic field, so EMF is inducing over there. So the three-phase induction motor, we are saying it's a three-phase induction motor which functions. That is basically it functions on the principle of electromagnetism. So we are saying it's a squirrel cage motor. Why we are saying? Because the rotor, two things are there, one the stator and the other is the rotor. Because the rotor, which is inside of it, it is just like a squirrel cage rotor. Okay, so it looks like a squirrel cage. Okay, so the rotor, which is a squirrel cage, it's made up of steel laminations, silicon steel laminations, and which is very highly conductive metal. And typically, it will be what I would say aluminium or a copper, which is just reinforced or embedded into its surface. So when we are applying the AC current, or when we are any alternating current is run, and which is running through the stator windings. Okay, so when AC current is running through the stator winding, obviously the rotating magnetic field is produced. And this induces a current, obviously it will induce a current in the rotor winding, and which produces the magnetic field. And the magnetic field which is producing over the interaction of the magnetic field that is produced by stator and the rotor winding. And when this magnetic field it is produced by stator and the rotor winding, it will produce a torque, and that will be on a squirrel cage rotor. Okay. So one big advantage of squirrel cage motor is we can easily, right here, talking about the advantage. So we can easily change its speed and torque characteristics when we are plotting it. So how we are changing its speed and torque by just simply adjusting the shape of the bars, which is there in the rotor. The squirrel cage induction motors are used, we are using in industry because they are reliable, self-starting, and easily we can adjust it, right? So now we are emphasizing on whatever the principle which is just behind about squirrel cage induction motor. Okay. So as you know that when we are talking about any motor, it's having a stator winding, it's having a rotor winding, right? So squirrel cage induction motor principle. So when we are having a three-phase supply, because this it will just say move on a three-phase supply. So when a three-phase supplies we are giving to the stator winding. So what will happen? So when we are giving a three-phase supply to the stator winding, so it will just produce a rotating magnetic field. So that will be a rotating magnetic field in the space, and it will just rotate. And this rotating magnetic field, it is just gaining a speed. And when we are talking about that speed, so we are saying that it's a synchronous speed. So when we are giving a three-phase supply to stator winding, so it sets up a rotating magnetic field in space, and this rotating magnetic field has a speed which we are saying that it's a synchronous speed, right? So that is the synchronous speed. So if somebody is asking you when we are giving a single three-phase supply, we are giving the stator winding, so it will just produce a rotating magnetic field. The magnetic will rotate. That will be in space. That will be a 360-degree over there. This rotating magnetic field, it will just have a speed which is known as synchronous speed. Now it's rotating now. So this rotating magnetic field, it will just produce a voltage or induce a voltage in the rotor bars, and the short circuit currents, right? It will start flowing in the rotor bars. So when we are applying this rotating magnetic field, it will just produce a voltage in the rotor bars, and the short circuit current is just flowing in the rotor bars. So these rotor currents, it will just produce a self-magnetic field which is just interactive with the field of the stator. Now the interaction will be there. Now the rotor field will try to oppose the cause, and due to that, it will just rotor starts following the stator magnetic field. So it will just move, and the torque will be reduced. So whatever the movement the rotor catches the following this rotating magnetic field, when it just catches the rotor magnetic field, the rotor current it will drop to zero, as there is no motion between the magnetic field and the rotor. At the time, the moment the rotor experiences zero tangential force, so then what will happen? The rotor deaccelerate from the motor. It is the pictorial view of this one. So we have aluminum entrance over there. We have the aluminum bars, steel laminations, and shaft, which is rotating. So it will deaccelerate. So what will happen after the deacceleration of the rotor? Rotating motion that is there between the rotor and the rotating magnetic field. We are saying the field it will re-establish, and hence the rotor current again being induced. So whatever the tangential force for the rotation of the rotor stored, and therefore again the rotor start the following the rotating magnetic field. So in this way, the rotor maintain a constant speed, which is just less than the speed of the rotating magnetic field of the synchronous or a synchronous speed. Yes, so how the construction will be there for rotor squirrel cage induction motor? Right? क्या construction हो रही है इसकी? So obviously it is having a stator, it is having a rotor, it is having a fan, and bearing will be there, right? So these are the things. These are the equipments we are employing in that, right? स्टेटर है उसमें रोटर है आपका फैन उसमें लगा हुआ है and have the bearing also. Right? Any doubt till here?
No, sir.
Right. So उसमें हमारे पास क्या क्या लगा हुआ है? एक हमारे पास है रोटर लगा हुआ है, एक स्टेटर है, एक हमारे पास फैन है, और फैन क्या है? फैन हमारे कूलिंग के लिए पर्पस के लिए भी यूज उसके इसमें है हमारे पास स्टेटर है, ये देखो जो आपके पास पड़ा हुआ है, ठीक है, ये एक पिक्टोरियल व्यू आपको दिखाया गया है इसका, because it's having the two poles on this one, either it will be साउथ पोल या हमारे पास नॉर्थ पोल है, ठीक है, ये जो आपको फिगर में दिखाया गया है ये सेंटर ऑफ स्टेटर पोल दिखाया गया है, नीचे आपका सेंटर ऑफ साउथ पोल स्टेटर पोल दिखाया गया है, whatever the flux which is inducing over there, it's a lines of flux, right? तो हमारे पास लाइंस ऑफ फ्लक्स बताया गया है, यहाँ पर करंट विच इज फ्लोइंग लेफ्ट टू राइट बताया गया है, जो करंट है हमारा फ्लो कर रहा है राइट टू लेफ्ट वो भी दिखाया गया है. So this is a pictorial view. I mean, we are talking about this one. Induction method, right? अब क्या है कि हमारे पास स्टेटर है बच्चे, एक हमारे पास रोटर है, एक हमारे पास फैन है, bearings है, that is the main parts over there. Stator है हमारे पास, obviously the core will be there and the winding which is just उसके ऊपर हमने वाइंडिंग लगाई हुई है, दो चीज ही हमारे पास है, तो हमारे पास वाइंडिंग लगाई हुई है, हमारे पास कोर है या वाइंडिंग है ना. So when we are talking about the stator now, so stator which consists of a three-phase winding, because these three phases are displaced by angle 120 degree. So these three phases, okay, and core is obviously there now, that is the metal housing. So the metals are such placed or the windings उसको हमने इस तरीके से लगाया हुआ है कि वो इलेक्ट्रिकली और मैकेनिकल 120 डिग्री पर स्पेस पे वो डिस्प्लेस्ड हो, उनका जो एंगल है बिटवीन थ्री वाइंडिंग्स का 120 डिग्रीज इलेक्ट्रिकली और मैकेनिकली डिस्प्लेस्ड है. अब जो माई वाइंडिंग्स है वो उसको हमने माउंट किया हुआ है एक लैमिनेटेड कोर पे, जब उसे माउंट किया है तो इट विल प्रोवाइड low reluctance fans that is generated by the DC current. Okay, so these are the windings which are showing here. इसमें जो हमारा तीनों windings हैं वो हमारे पास 120 पर डिस्प्ले। दूसरी हमारे पास होती है रोटर। When we are talking about second part, that is the rotor. So rotor is obviously it's a great it's a main thing over there. So rotor जो हमारे पास है वो हमारे पास रोटेशन कर रही है, वो मैकेनिकल आउटपुट ला रही है. We are giving some electrical energy. So what will happen over there? So whatever the output of the rotor, okay, whatever the output of the rotor, that will be obviously it will maintain then the nameplate and whatever the horsepower, वो भी nameplate पे लगी होती है जो शाफ्ट के पास लगी होती है, राइट. अब आपके पास ये रोटर आ जाती है हमारी तीसरी हमारे पास रोटर. एक हमारे पास जो रोटर है वो एक लैमिनेट, उसको लैमिनेट किया होता है. तो लैमिनेट क्यों किया होता है? क्योंकि जो हिस्टेरेसिस और जो आयरन लॉस है वो कम हो जाए, राइट. उसको स्क्यू किया गया होता है कि कुछ उसमें वो फ्लक्चुएशन ना हो, कॉगिंग ना हो when we are operating it. No? Okay. Now the third thing is the fan over there. Why we are imposing or implementing a fan over there? No? So fan we are attaching on the or say back side of a motor. No? So why we are imposing a fan over there to provide the heat exchange. Okay. जो उसमें heat exchange हो उसके लिए हम provide करते हैं, and it will maintain the temperature of the motor. Okay, we are maintaining the temperature of the motor under a limit. उससे ज़्यादा अगर टेम्परेचर होगा तो आपकी मोटर जो है वो डैमेज हो सकती है. So we are providing a fan over there. And bearing also we are providing because we are providing on the base of the rotor motion. We are providing also for smooth operation. We are providing for the smooth operation and the rotation of the motor. So now we have to see what are the applications of squirrel cage induction motor. So we are obviously, because 90% of this motor we are providing using in the industries, that is squirrel cage induction motor. Why we are using? Because they are mostly we are using for the industrial applications, right? So we are using this one for the centrifugal pumps. We are using for let me say this one industrial drives. We are using for blowers. We are using it for fans also. We are using for machine tools. So advantages because it's having a low cost, it is having the low maintenance, speed regulation, good speed regulation is there, the efficiency is good, better heat regulation barrier, small and lightweighted, explosion proof. We have a disadvantages also because very poor speed control. Because they are obviously it's energy efficient while driving a full load, but they will consume a lot of energy. So they will start up. So they are very, say, fluctuation, sensitive load fluctuation. Right? So now the basic difference between the squirrel cage induction motor or induction motor or slip ring induction motor, because in slip ring induction motor we are providing the resistance over there. So these are the difference. So when we are talking about the cost of squirrel cage induction motor that is low. When we are comparing with slip ring induction motor, maintenance is also low when we are comparing with the slip ring induction motor. But the speed control is poor. Squirrel cage induction motor when we are comparing with slip ring induction. Automation that is good over there. We are talking about squirrel cage comparable to the slip ring induction motor. So in the next class, we will do classification of squirrel cage induction. Right? Any doubt? Any doubt till here?
No, sir.
I'll just provide you. You just give me your what I'm saying is on email IDs now, so I can send you the notes. Right?
Okay, sir.
Email IDs दे देना आपने सबके. So I will just provide you notes. Right? ठीक है जी. जी
ठीक
Vishal Jasveer. Vishal is there, right?
हेलो
Jasveer Singh.
सर ग्रुप में करनी है.
हाँ मैं सेंड कर दूंगा आपको. नहीं नेक्स्ट क्लास में हम अगला चैप्टर शुरू करेंगे. ठीक है.
ओके सर.